Harvard model is centralized control unit. Can you solve simple? But yeah, I will do that. Question is, I asked, what is the difference between Harvard model and von Neumann architecture? Harvard architecture and the von Neumann architecture. Yeah, I will record this one.
Recording in progress.
So as I mentioned, we are covering session 1, 2, and 3. In session 1 and 2, we are talking about this computer. Session 1, we are talking about computer generation and basic basic information about computers, right? Hardware and software both, especially the evolution. Let me share my screen. Yeah, difference in memory access. Yeah, the von Neumann model, there are 2 units. Yeah, there are 2 units. Okay. Yes, this is day school 1 revision. Since you have your first activity on next weekend, actually weekend, not weekend, Sunday and Monday, it will be open for 2 days, Sunday and Monday. Monday is the last day. So I will share all the necessary information. It will be an online quiz, so you can do it. You can find free time and do it. It will be open for like once you open the quiz, you have to do it within most probably 1 hour, 1 or 1.5 hours. But anyway, quiz is available for 2 days. You can pick suitable 1.5 hour time slot and do the assignment, right? Okay, so let me share my screen. MCQ, auto mark questions. So okay, so here we are talking in first session evaluation. We are talking about the evolution of computers now. So here you don't need to memorize all these things, right? Basically, if you can distinguish these generations 1, 2, and 3, that's enough, right? As an example, in second generation, when it comes to third generation computer, so they use these transistors, right? Here, so in this first generation computer, these can you see all these important things? All these important things are bold, so you can understand what are the things going on in first generation. If you can distinguish between these things, this generation, that is enough, right? You don't need to memorize all these years and everything. But basic things like generation 1 start from 1937 and generation 2 start from 1951, something like that. Those can, if you can memorize those things, that is totally enough, right? So here third generation, so in third generation, something like build large scale integrated circuit, something like that. Those are the main points, right? Then this fourth generation, here still we are using this von Neumann architecture, right? So for most computers, von Neumann architecture is the fundamental architecture, right? So all the developments were made for this architecture, and actually they were additions, right? So if we ask you to distinguish, it's better to use these diagram, right? So these are not that hard, no? So here in von Neumann architecture, these arithmetic and logic unit can access the memory, right? Here, it has memory access. And also ALU can access input-output units as well. So I think you know what is input-output units. Can you give me a few examples for input and output units? What are the few examples for input unit and a few examples for output devices?
Input devices, mouse, output devices, printers.
Okay, so main output device is what is the main output device? If you take a
Screen.
Yeah, monitor.
Monitor.
Yeah, that's right. So input device, keyboard, mouse, everything, right? Whatever you use to give commands or give instruction to the computer, that is an input device, like a keyboard, mouse, whatever. So output device, you get output. Computer sends, actually computer share their information with us using output devices, right? So this arithmetic and logic unit, right? We have discussed a little bit about arithmetic and logic unit in the first day school lesson. So all the arithmetic and logical functions, calculations, logical, what do you call, logical things will be done using this unit, right? So in Harvard model, all the things are going through the control unit, right? So control unit, can somebody tell me what's the function of control unit? Actually, this should be a CU. This should be ALU. I have to check with the course team because they are the one who prepared this course material. So this is the control unit, and this is the arithmetic and logic unit. Can somebody tell me what's the function of control unit?
Control unit control the other part of the computer. What to do the function? It is a control unit.
Yeah, basically it handles all the controlling part, right? So normally we provide information using, we provide instructions using programs and using input device. Based on those instructions, control unit handles the other equipments like memory and other input and output devices, arithmetic and logic unit. So even it has memory access, even ALU has separate memory access. Someone has to be there to control it now. So when to do the arithmetic operation, like if you take this arithmetic operation A plus B. So even this is available in the ALU. Someone has to tell to do this operation, right? Then it will be moving to separate memory location. The answer will be available in a separate memory location or separate register. And if you want to put this one into memory, main memory, we have someone has to tell it, right? So all the controlling part, input and output devices and other devices, units, everything is controlled by control unit. So that is why we call it as a control unit. In nowadays computer, we call it as a CPU, central processing unit, right? No, actually, whole unit is central processing unit. In central processing unit computers, they have only one control unit, right? There are some advanced computers, they have multiple control units. But anyway, so I think you get the basic idea, right? So it controls everything. Okay. Okay, hope you can see right now. So actually, this is your course material. It is shared with you as well. Right? So if you haven't downloaded it yet, it is available in the LMS. You can download it. Right? So that's the basic difference. Right? You can read this, but when you are answering questions like this, it's much better to use these diagrams. Right? So with the help of diagram, you can explain a lot of things. Right? So otherwise, it is really hard to explain all these things now. So drawing this, if you can draw these diagrams and say based on the according to above diagram, this thing is something like that, right? You can explain this, explain using the diagram, right? It is the easiest way. Also, you can share information. You can share clear information, right? If you try to explain everything in words, sometimes you may not be able to explain everything correctly, right? So, but if you use these kind of diagrams or diagram kind of things, the explanation is really easy, right? So especially this what is mean by computer architecture. These are really common things, right? You have to understand what is computer architecture, right? So if you are you are studying computer architecture in secondary school, in secondary school we talk about computer architectures. What are the computer architectures, and how the different types of computer architectures, and what are the things available in computer architecture, and everything we are discussing, right? Before that, you need to know what is computer architecture, right? Okay, so basically that's that, and other parts. I think these are these information. These are like nowadays these are more like general knowledge, right? So all the computer people knows these things, right? Even in diploma courses, like certificate courses, they teach these things, right? Future generation, now fifth generation, there are some improvements. We talked about these things in first day school as well. So okay, so in the end, there are no activities, right? Okay, so that is that. I think you can read them and read it and understand. But this is really important. Number systems. So if you go through this final exam, this is the last year final exam paper. I think one paper is available in the LMS as both the answer script and the final paper. So you can go through that and get an idea about how it is arranged, right? So basically, there are 4 questions, right? Architecture, the structure will be the same, right? First, there are 4 questions. First question, we normally allocate 40 marks for first question, right? So it is the without this question, it is really hard to get the pass mark, right? One mistake which is made by a student is they skip this one, right? So actually most of the marks, right? So you can so if you can here, this third question, you have to draw flowchart, right? So you are learning flowcharts in 3467, as well as we had some workshops and everything, no? So basically, if you draw the flowchart, right, even it is not complete, you can get 10 marks, right? So it is out of 100, right? You have to understand the structure, especially. So you don't do those kind of mistakes, right? So here explain the function of ALU. These are theory questions, right? So you can get these marks easily, right? Accumulator based architecture, it might be Harvard architecture. Then we might ask theory questions here, right? So in first question, it as I mentioned, we allocate 40 marks. So in that 40 marks, the second questions, most of the time these are based on session 1. Right. Theories which is in session 1. Actually, we will cover session 1 from this first question, and the other parts are computer architecture questions. We will talk about these things in second day school, actually. Right. Okay. So writing assembly program is also very important, right? Even if you haven't complete the assembly program, you can get marks, right? So that is what I am. That's what I want to say, right? Some people think no, if you cannot figure out a whole program, you don't need. It's better to try it out, because at least you can get some marks, right? So if you can do a whole question, you can get 40 marks, right? Then you get the pass mark, right? So that's what I want to talk about is this one, right? So this is the second question. No, actually, question one, part 1 and part 2, sometimes part 2 is based on session 1, right? Not from other sessions. There might be theory questions in this question. Actually, what I want to talk about with you today is this one. This is the number system question, and you can get 20 marks, right? So actually, if you understand how to do this calculation, it is straightforward, right? So there are no special theories and everything. There are no, if you take like as an example, if you take converting digital to binary, there's only one method, right? So if you can understand the method, so it is straightforward. You can get full marks. I keep saying this again and again. If you here, there are special there are steps to do this now. So you have to mention all these steps to get the full mark, right? So sometimes actually you can bring calculators to the exam hall as well. Sometimes you can get the answers using calculators as well, right? At least part of the question answers, but we are not giving any mark to the final answer, right? You have to mention all the intermediate steps, otherwise we may not be able to give marks, right? So let's say if you allocate 2 marks for one question, we will give 1 mark for intermediate steps and 1 mark for answer, right? So if you have mentioned answer only, you may not give any mark. But if you have intermediate steps as well as answer, you can get 2 marks, something like that, right? So always write the intermediate steps, right? So I will discuss few things. I will explain how to calculate these things as well. Yeah. Even in normally students get 20, at least 18 marks for these questions. because it is straightforward, right? Okay. So there are some questions in the chat as well. Cache memory, I will explain it later. Actually, cache memory, we might be able to talk more about cache memory in our secondary school. But anyway, okay. Are there any word limit to take the full marks? No, actually. So you have to understand this. Like these are engineering subjects. If you can describe within one sentence, that is, if you can explain everything using one sentence, you can get full marks, right? That's why I told you to use diagrams. Like using diagrams, it is easy to explain, right? So you don't need to write like essay, but if you can point out the answer with in one sentence, that is totally enough, right? Sometimes you may need to explain a little bit more, like if we ask some steps or the differences, there might be several differences, right? So you have to mention all these things, but we are not. There are no word limit. Question 1 is from session 1, not even from 2. No, question 1, part 1. Most probably part 1. Sometimes we might ask, we may put question. I mean, sometimes we might put 2 questions, right? So in the whole the other parts, these parts, especially 2, 3, 4. These are based on computer architecture. It is session 4 to 8, I think. Right. So that's the parts we are covering in secondary school. Actually, this part we are covering in the lab. Actually, in day school we are not talking about assembly programming, but in the lab we are covering this part. Right, you write assembly programs and you run it on a simulator. Yeah. Okay. Else, will we be given study leave before? Yeah, I think you get like week or 2 study leave, most probably. I don't know. You have to check it. Check the activity diary. Since this course is going on a slow pace, you don't need to have this kind of study leave, right? If you practice every day, like if you do these activities by your own, you don't need to study hard, right? So yeah. Okay, so final exam is in the second semester, end of the second semester. TMA is not a test. TMA means tutor marks assessment. Assessment, you can refer anything, right? Even you can ask one of your friends, but don't do that, because doing I think you have to do the TMS by your own, because all the final exams and CAT exams are based on these TMS, right? So so you can refer to anything. Actually, tutor marks assessments, you have to refer the books and other things to answer this question. Actually, you have to, first of all, since this is open for like 1.5 hours, you have to refer. You have to go through the course material. Otherwise, you won't be able to find out the exact answer, right? But anyway, it is you can refer anything, and it is not a test. Even it is an online quiz, but it is not a test, right? April, actually we have not April. See the check the activity diary. We have Cat 1 in this semester, and Cat 2 and final exams will be in the next semester. I will upload this year paper into the LMS. Actually, the structure is same, right? You don't need to do each and every paper. If you can understand the structure, you can get ready for the final exam. That's why we didn't upload everything. My laptop camera was not. I think you are talking about some other course, right? So you have to contact that particular course coordinator. Otherwise, actually, I may not be able to answer for that question. So you have to contact the relevant course coordinator, right? 19 February test. There are no tests on 19 February. No final exam in the first semester. Yeah. TMA gave ultimate. Yeah. I already. Where is that? So if you go through this course, this LMS. Yeah, if you there's an announcement. So TMA 1.1. Actually, we have two TMAs, TMA 1 and TMA 2, and each TMA is divided into two parts, right? So TMA 1.1 is an online quiz. You have to do it in the LMS, right? So it will get you can get 30 marks from TMA 1 here, and rest which means the 70% will be allocated for TMA 1.2, right? So actually this is the you have to actually this assignment is a essay type assignment. So you have to provide essay type answers and convert it into a PDF form and upload it to the LMS, right? So I will share all the information eventually. So yeah, that's that. Even TMA 2 is divided into two parts. There's an online quiz part and essay type part, right? So here TMA 2.1 we allocate 40% from TMA 2, but TMA 1.1 only 30%. Course coordinators Gmail, not Gmail. Email is available in the course communication part, right? So go to that particular LMS and in the course communication, you can find the course coordinators email. About on-site workshop on 19th February, actually not the person who is organizing that. I think it is organized by someone else. So if you have any question regarding the workshop, please ask those questions through learner support page, right? So they will provide you answers. Arrange other team. We haven't given Actually, we didn't give TMA yet. TMA 1 is coming on next weekend, so you can do it in next weekend. No lab test on 19th. For this course, I don't know about other courses. For this course, there are no lab tests on 19th. First activity is coming on next weekend. Actually, not weekend. 19th and 20th. The assignment will be available on both these days. Okay, so I think that's enough. I will answer the other questions later. Otherwise, I won't be able to cover this calculation part. Right. So the calculation. Okay, so this is the final exam question. Even the exam paper which is available in the LMS has the same type of questions, right? Only numbers are different, so you can try it out and you can evaluate yourself. Actually, that paper is available in the LMS. So if you can do that question, the second question, it is more than enough, right? You have covered everything. Okay, so this is the question. I think you know how to convert this decimal number into binary, right? So this is the easiest one. Basically, you have to divide, right? In here, there are two parts now. This part is the whole number part. This is the fractional number part. So you have to do this actually whole number part. You have to use one method, and to convert fractional part, you have to use another method, right? So for whole number part, you just need to divide 127. You have to divide by 2. Yes.
Can you zoom it for a little bit more?
You can't see that?
Can see, but little bit more zoom it for that.
Okay, 100 bits. Is it enough? Is this enough?
Okay, thank you.
Okay, so as I mentioned, there are two parts: whole number part and fractional part. Whole number part, you have to do this calculation separately. Like you have to do the conversion to whole number part first, and then you have to do the calculation for fractional part as well, right? So whole number part, you just need to divide by 2. Divide by 2 means 63, and there's a reminder, right? So I think you can understand this thing, right? So what is reminder? And we talked about these reminders and everything in the first day school. And also there are plenty of available YouTube availables. YouTube videos are available for this section. So you can refer to those things as well. Actually, I have given some reference videos as well. So everything will be clearly explained. So I just explain the calculation here. So you divide by 2, and again you divide by 2. Then it is 31. Here also there is a reminder. Again divide by 2, 15. Reminder, and again divide by 2, and reminder, again divide by 2, and reminder. So again you divide by 2, you get 1, and a reminder. Right, so then you have to write from bottom to top. 1, 2, 3, 4, 5, 6, 7. Right, so this is the whole number part. 1, 2, 3, 4, 5, 6, 7. Then here, this is the fractional part. You have to multiply. Right, here you divide by 2. Now for fractional part, you have to multiply. 2 to the power 0.23 multiplied by 2. The answer is 0.4. 0.23 multiplied by 2. The answer is 0.46. There is no reminder. Right. So again, you take this value 0.46 and you multiply by 2. It is 0.92. Again, there is no reminder. Right. Again, you take this value 0.92 multiplied by 2. Here you have a reminder, right? So it is the answer is 1.84 now. So answer is 1.84. Actually, we put this one here, right? So even if you put this one here, it is okay. But when you are taking this value to here, you take only fractional part 84 because you have this reminder here, no? So again, you multiply by 2 and you get 1.68. There is a reminder, right? So you can put 0.68 and reminder here, but anyway, it's up to you, right? Right. So then here we are writing this value from top to bottom, not bottom to top. Here, this integer part, whole number part, we wrote from bottom to top, but here in fractional part, we write top to bottom, right? So we start from here, 0, 0, 1, 0, right? So in your final exam, going up to 4 decimal points or binary points is enough, right? So sometimes students go up to like 8, 9 steps, but you don't need to do that, right? So even if you write 4 numbers, you will give full marks, right? But anyway, whole number part you can't do that because you have to do the calculation or whatever the number is, you have to put it here, right? But when it comes to the fractional part, you can stop by 4 numbers. That is enough for final exam. But when it comes to the assignments, essay type of assignment, it's better to go a little bit further, like at least 8. Okay, so that's that. So both these questions are you can calculate values using that method for using that method here, and here you have to convert this binary number into decimal number, right? So normally what we do is there are steps, right? So here I think you can remember, like what are the steps? You divide this whole number part and fractional number part, and then you divide this number by 27, and you take the fractional number 23 and multiply by 2, and you get some answers, right? So these are the intermediate steps. You have to mention all these intermediate steps to get the full marks, right? Then you have to put final answer as well. For when it comes to the binary to decimal calculations, binary to decimal, the way to do is you have to write down this value like 1 0 1 1 0 1 1 or this are right. So then you have to put corresponding 2 to the value 2 to the value 2 to the values, like this is 2 to the value 0, this is 2 to the value 1, 2 to the power, sorry, 2 to the power, this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, right? Then you can multiply this thing. 1 multiplied by 2 to the power 0, this one 0 multiplied by 2 to the power 1, 1 multiplied by 2 to the power 2, 1 multiplied by 2 to the power 3, and this one 0 multiplied by 2 to the power 4, 1 multiplied by 2 to the power 5. Then you have to add all this one. This is 2 to the power 0 means 1, no? 1 by 1 means 1 multiplied by 1 means 1. Here it is 0. We are multiplying by 0 now, so it is 0. This is 2 to the power 2 means 4. 1 multiplied by 4 means 4. Right? So this is 2 to the power 3 means 8. So 8 multiplied by 1 means 8. And then 16 multiplied by, yes? Yes, do you have any question? Okay, so this is 0. 2 to the power 4 means 14, sorry, 16. Even it is 16, it is multiplied by 0, no, it is 0. Then 2 to the power 5 means 64. 64 multiplied by means 64, right? So you have to add all these things. This 72, 79, right? Actually, I wrote this. This is 1 0 1 1 1 0. There's another one, right? So anyway, so this is the method. So you can. So actually, I took this number, right? So I missed one here. You can anyway. These are the steps, right? You have to put all these 3 steps. First of all, you have to write down these 2 to the power values. Then you have to multiply it, and then you have to add all these things and get the final answer. Actually, this is the base. You have to write the base as well, right? 79. Sorry, base is 10. Right? This is because this is
79, 71.
71.
77, sir.
64, 72, 76. Yeah, 77. Yeah, thanks. It is 77. So you have to show all these calculations, intermediate steps, right? So then only you can get the full mark, right? So then, yeah, perform this operation, right? So this is the division. So division, it is also, we are using the same method like decimal division, but since these numbers, these binary numbers are new to you, you may have found a little bit difficult, right? So anyway, so if we take this one, 1011.0 101 divided by 1101, right? Here, can you see this part? Actually, this part this one is larger than this one, right? This is 1101 now, but this is 1011, right? So you cannot divide this by this value, right? So definitely you have to put 0, right? Then we come into this what do you call fractional part. Now we can put this value here. C1, this value you have to write down here 1011, and then you can subtract. Actually, this is how we do decimal calculation as well now. So let's say as an example 23.5 divided by, let's say, 25. So here 23 cannot be divided by 25. So we put 0, right? Then 23. So how many 23s are available? Shall we take an easy number? Shall we take a small number like 12 point, no, not 12 point, 3.5 divided by 6. So here this value is smaller than this one. So you cannot divide by 6. So you have to put 0. Then you have to put 6 here, right? So 6 by 5 is 30 now. So you can put 30 here. No, 6 by 6 is 30. So you have 5, right? Remainder is 5. Then 5 again, you cannot divide by 6. You have to put 0. Then 50. This can be divided by 6. This is 30. 5 multiplied by.
Excuse me, sir. Can you explain again? I can't understand, sir.
Okay, so if you take like these are decimal divisions. Let's say you want to divide 3.5 by 6. So here, if you take this whole number part, you cannot divide it by 6 because it is smaller than 6. So it is 0. Again, then this decimal point comes here. Then you can then it is 3.5 now. So you can divide. Let's say 35. 35 can be divided by 6, right? So what is the highest number that can be divided? I mean, without a reminder, it is 5 now.
30.
5 multiplied by 6 is 30.
30.
30. So 30 means 2.0. So you can subtract this. 0.5 comes here. Then here again you cannot divide this by this because it is smaller than 6. So again 0. Then you take another 0 from here, and now this can divide, right? You can multiply 6 multiply by. There is a reminder, right? You can get another 0 from here and something like that. You can go like you can divide further, right? Same method we are using in binary as well. So you have to divide the 1011.0101 by 1101, right? So as in first example, you cannot divide this by this because this one is bigger than this one, so it is 0, right? 0 point. Now you can write this value. Right? Now if you take all these, if you take all these, now you can divide, right? So now you have to write this number here, 1 0 1 1, and now you have to subtract, right? So this is, let's say, 1 multiplied by this one is this one, right? Now you have to subtract 1 0 this is subtraction, so you subtract 1 from 0. You can't do that, no? So you have to take take 1 from here, right? So 1 0, you can subtract 1 0, so you can subtract 1 from 1 0, so it is 1. Then now it is 0. There is 0 here, so 0 subtracted by 0 means 0. 1 minus 1 means 0. 1 0 minus 1 means 1, right? So again, this cannot be divided by this one, so again 0. Oops, sorry. No, you can take this one. No, here this is the remainder, and you have to take this value. I will draw it using a separate color. You have to take this one, right? Again, you can, it's a big number, it's larger than this one, so you can divide it, right? 1 1 0 1 1 1 0 1 1, let's say 1 1 subtracted by 1, 0 1 1, right? So we are you cannot subtract 1 from 0, so you have to take 1 value from here, but it is also 0, right? You have to take 1 from here, right? Then 1 0 can be subtracted by 1, so answer is 1. Now it is 1 here. 1 minus 1 means 0, right? Here also you took this 1 here, so it is 0, right? So 1 1 1 1 0, then you can take this value here. Actually this is smaller than this one, so it is 0, something like that, right? So this is the method to subtract. There are a few questions. 2B questions. You mean this one? Okay, I will explain after this one, right? Anyway, so I think you can understand this method. Only thing is you have to divide. You have to how can I say? You have to be very careful when you are using binary numbers, because when you are taking reminders from next number, sometimes you may miss, like even if you take reminder, you may think you mistakenly think that there is a number in the front, so I mean, when it comes to divide, you divide this one again, even you took this number to the next value. So what I want to say is these are not that hard, but you can make mistakes easily, right? So division is kind of a little bit difficult. Actually, that's why we give more marks for these parts, right? So these parts you get only one mark, but for these ones you get more marks, right? So you have to be very careful. Yeah.
We can decimal numbers generate binary numbers generate decimal numbers and division, and again binary numbers.
Yeah, you won't get any mark for that one. So that is what method I explained this one in. I told you this one in first day school lessons. You can divide. You can convert this number into decimal format and convert this number into decimal format and divide. Like let's say A and B. You can divide A by B easily, but you won't get any mark, right? So you have to. If it is mentioned in binary, you have to do the binary division, right? So that is the way. Even whenever we mention a particular number system, we have to use that particular number system for calculation as well, right? Right. So yeah, that's that. And this part, someone asked about this part. This is also not that hard. Only thing is, I think you know how to do this part, no? So again, you have to write it like this one, 1011 point 3 ones are there. No? Point 0101. Right. So these things, you know, this is 2 to the power 0 question. This is 2 to the power 1, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Right. So then 0, this is 2 to the power minus 1. This is 2 to the power minus 2, 2 to the power minus 3, 2 to the power minus 4. Right. Here, if you can multiply this one by 2 to the power 0 plus 1 multiplied by 2 to the power 1 plus this one 1 multiplied by 2 to the power 2 plus 0 multiplied by 2 to the power 3 plus 1 multiplied by 2 to the power 4. Right. This one 0 multiplied by 2 to the power minus 1. This is 0 multiplied by 1 divided by 2. Right. 2 to the power minus 1 means you can put this one in the bottom, so you can remove this minus mark. Right. Plus 1 multiplied by 2 to the power minus 2. Again, this one you can write 1 multiplied by 2 to the power, multiplied by 2 to the power divided by 2 to the power 2. Right. So this one 0 multiplied by 2 to the power 3 and 1 multiplied by 2 to the power minus 4. This one 0 multiplied by 2 to the power 3 plus 1 multiplied by 2 to the power 4. Right. So you have to do this addition. This is a fractional part. The answer is something. You can get the answer, right? So here also you have to calculate. Here it is 0. 0 plus here 2 to the power 4 means 1 divided by 4. Again, this one it is also 0 plus this part 1 divided by 60. Right. I think you can do this calculation. Right. So you can put this thing, you know. So you have to put the answer here, and this thing is for the fractional part. right? So you can get the answer like this. Right, so these are the correct steps. You have to follow the correct step. Also, you can actually, if you are taking, these parts, right? Since you are taking calculators with you, you don't need to do these manually, right? You can do these calculation using calculator, but these intermediate steps you have to show. Otherwise, you won't get any mark, right? So actually, what we want is your we want to test your knowledge about how to do this calculation, right? So that is why we are not asking you to do these calculations manually. I think you have done this since your primary classes, so we don't need to check the addition knowledge, your addition subtraction knowledge. But now we are testing your this conversion knowledge. Right? That's enough for us. So anyway, okay. So that is how you do that one. These complement methods, right? So one's complement to actually you have to do this again. You can do this like let me take. Okay, so here these are decimal numbers now, so you can easily get the answer here, like 65 now minus 65. You can convert this one into binary format. So that is one method, but we won't give any marks for that, right? So you have to use 2's complement method to get the answer. I mean, if you need the marks, you have to use the correct method, right? Binary method, right? In binary method, first of all, you have to convert. There are 5 steps to convert to calculate using 2's complement method. First step is you have to convert these values into binary. Actually, that is not the first step. Let's say it is 0th step. You have to convert this one and this one into binary value, binary numbers, right? So if you convert this one, I think you know how to convert, right? So you have to use the correct method and convert these two numbers. If you convert this number 21, it is I think 0 0 1 0 1 0 1 or something. Yeah. So 86. Not minus 86. You have to get the whole number. 86 means 1 0 1 0 1 1 0, right? But you cannot write like this in final exam or any exam. You have to do the calculation, right? You know how to calculate. You know how to convert decimal value into binary, so you have to use that correct method, right? So then you get binary numbers here. Then you have to convert. You have to complement. You have to get the step one. This, let's say this is 0th step. Step 1 is converting these numbers into 1's complement number, right?
Excuse me, sir.
Yes.
So shouldn't 21 be the other way around? 10100?
21. Let me check. No, this is correct.
So can the number start with a 0?
Yeah, it's possible. Like yeah, the thing is, the thing is when you are using this ones complement and twos complement method, let me take a pen. Okay, so when you are converting using these type of methods, you have to maintain the number of slots, right? Here, can you see there are 1, 2, 3, 4, 5, 6, 7 slots. So here, if you have 7 slots here, you have to maintain 7 slots here as well, right? Otherwise, the calculation will be wrong, right? So binary number of 21 is 10101, but since you have to maintain this number of slots, you have to put 2 zeros here, right? So otherwise you cannot do this calculation, right? So basically I think you will understand when it comes to the next step. So here so this one yeah, this is the minus sign, you know. Yes.
So 21 is 10100.
Are you sure?
Yes, sir. I think she is fine.
Yes, sir. Yes.
1010. Let me check.
No, sir. No, sir. 21 is 10101.
Correct.
No, sir. Last one is 2 into power 5 into 32, I think. And 32 and plus 2 into 20 is 133. Right.
Sorry, sir. I have made a mistake. It's correct.
Yes, you are right, sir.
Yeah, it's correct. No? Actually, you can double check using this scientific calculator as well, right? It is available in the Windows as well. So this is, let me share that one as well. So if here decimal 21 means it is 101, right? So you can check your answers using this calculator as well, right? Even in final exam, right? You have if you have a scientific calculator, you can check your answer, but that's why we are not giving any marks for the answer, right? You can get it from the calculator. You can take it from the calculator. You can calculate it from the calculator. So you have to mention all these correct steps. So you cannot use programmable calculators, but you can use scientific calculator like MX991 kind of calculators. Yeah, MX some of FX ones. The basic FX ones are also okay. Yeah, it's fine. You can bring scientific calculator, but it has to be an unprogrammable scientific calculator. You don't need to purchase, like if you can borrow it from one of your friends, that is enough, right? Even for the final exam, actually you need it for your exams, no? So but when at home you can use your Windows calculator, right? It is also, all the functions are there, no? You don't need to purchase it because now it is really expensive, right? Those days it is not that expensive, but nowadays it is really expensive, right? You can ask, you can borrow it to one of your friends. Okay, so I think it's almost like the basic ones is also 8,000 rupees, like this big, since you don't need. Is that so? So it is expensive, so you can borrow it one of your friends. Okay, so what did we? Okay, so oops. Yeah, those days it was like 1,500 and 2,000, around 2,000, right? So now it is really expensive. You don't need to buy it, right? But anyway, it's really helpful if you can bring one of scientific calculators to the final exam, because you can do a lot of calculation, right? Since you are not testing your addition and subtraction knowledge, you can use calculator, right? Anyway, so 21 means 1 0 0 1 0 1 0. 86 means 1 21 0 0 1 0 1 0 1 86. Okay, so here this is the 0th step. Let's say step 0. So you have to convert this one and this one into binary form. Actually, this is the minus number now, so you have to take this one. This you can keep it like this because it's a plus number, so you can the plus even 1's complement of plus number is the same as this one, right? So you have to take this one like this, but since this is a minus 86, you have to complete. You have to take the first not first 1's complement value, right? So 1's complement value means actually theory is a little bit different, right? Theory means you have to subtract from 1 1 1. You have to subtract this value 1 0 1 0 1 1 0. You have to subtract this value from this value. In this value, all the slots are one. So you have to subtract this one from this one. Actually, what it happens is it complements all these numbers. Complement means if there is a 0, you have to put 1. If there is a 1, you have to put 0. Here 0, here 1, it is 0, it is 1, it is 0. Right? So even if you subtract this one from this one, you get the same answer. Right? So in theory, this is the correct way, but you can check your numbers using this one. Right? So whenever you see a 0, you have to put 1. Whenever you see 1, you have to put 0. Right? So basically, this is actually this is the steps to step 1. Step 1, you get the complement value. Actually, this is the 1's complement value. Right? So then step 2, you have to get the 2's complement value. Then you have to get the 2's complement value. To get the 2's complement value, you have to add 1 plus 1. Right? Plus 1 means 1 plus 1 means 0, and there is a remainder 1. Then there are no numbers, right? So 0, 1, 0. I think this is clear. Right? You just need to add 1. That's all. Right? So then this is the 2's complement value. Then step 3, you have to do the calculation, this calculation. But here we already took minus 81, and you don't now. Since this one, actually, when you get the 2's complement value, this is the 2's complement value of minus 86, right? Not plus 86. This is minus 86. Then you can directly add this one to this value, right? So keep in mind that, so here this is a plus value and there is a minus value. Using 2's complement method, we calculate a binary value which represent minus value, right? So that is why we have, you first of all you get the first complement value, then you add 1, then you get a number like this, right? Now you have to do the calculation. 0 0, this is the first number, this one, 0 0 1 0 1 0 1, then you have to add this one, 0 1 0 1 0 1 0, right? Now you have to add because this number means minus. Yes. Close complement. No, actually, 2's complement method is for represent binary values. Sorry, minus values, not for plus values. Plus values you can take directly, but when it comes to minus values, yeah, there are several steps, right? So you can take this one like this, and you only have to calculate minus value like this, right? You can put this value here, and you can do the addition, right? Then you get this value. Let's say 0. 1 plus 0 means 1. 0 plus 1 means 1. 1 again 1. Again 1 1 and 0. Right. So this is the answer. If you come this far, you will get like 80% from total mark. Right. Let's say you 5 marks are allocated for this one. Most probably you will get like 3 or 4 marks. If you come, most probably you will get 4 marks out of 5. If you can you can get this answer, right? So, but anyway, this is not the final answer. You have to convert this one. Yes.
I have a doubt. 21 is 0 0 1 0 1 0 1 and 8 minus 86 is 0 1 0 1 0 like. But the 21 is last one is a 0. Then how to subtract the last one part, the 0 to 1? Because no more the last part, last 0 and 0. Then
this one.
Yes, sir. This one. Then how to subtract that? Because we
No,
want to.
you are not subtracting. You are adding.
Yeah. Okay.
So that is why we use 2's complement method to eliminate this minus mark. Right. So if you now this value means minus 86. Right. So now you don't need to subtract. You just need to add this one into this one.
Oh, okay. Okay. Thanks.
So so then yeah.
Could you please explain from step 1? I couldn't understand well.
Step 1, actually you have to complement this value, right? So you get this one. This is the one you want to convert now. So you get this value. Then you have to complement. Complement means you convert. Complement means whenever you see 0, you have to put 1. Whenever you see 1, you have to put 0. Right? Here 1, it is 0. Now 0, 1. Here 1, you have to put 0. This is 0. You have to put 1. This is 1. You have to put 0. Is it clear?
Yes, sir.
So this is
Then why have you placed 1 1 1 1 above that row?
Yeah. The same method. Actually, this is the theory. In theory, you have to subtract this number from this number, right? All ones, right? All the sorts are ones. So even if you subtract this one from this one, you get the same answer, right? So that is this is actually this is the easy method. But in theory, you have to subtract 11111 from this number from 11111 and 7 ones actually. So this is the theory, and this is the easy method, right? In easy method, you can complement, right? So whenever you see you have to put 0, and whenever you see 0, you have to put 1. Whenever you see 1, you have to put 0, right? It is better to use the theory, but anyway, you can write the answer using that easy method. No, you just need to put a few ones. That's all. It take much time now, so it's better to use theory. But anyway, actually, I told this one because you can double check your answer, right? Anyway, you can get the answer easily now, so you don't need to subtract everything. You can get the answer easily. So then after that, you have to add 1 plus 1, right? Plus binary 1. 1 plus 1 means
That is second complement method. Am I right?
Yeah. To convert, this is the first complement. This is the answer for first complement, and now you have to convert this first complement value into not first complement, one's complement, right? One's complement value. This is the one's complement value. You have to convert this one's complement value into two's complement value. To do that, you have to add 1, binary 1 plus 1, right? 1 plus 1 means 1 0, no? So you have to put 1 0. Then this 0 is here, this 0 is here, this 1 is here, this 0, this 1. So you just add 1. That's all.
Oh,
now,
for all numbers, only 1.
Yeah. That is how you do two's complement, right? So you get the first one's complement value. Whatever the number is, you add 1. That's all. Right? So then you get two's complement value of minus 86. This is really important. Not 86. You get the two's complement value of minus 86. Right? So now you can do the addition. 21 plus minus 86. It means 21 minus 86 now. So you can add these two numbers. Here it is addition. So you can get this number, right? So this is kind of an intermediate answer. But anyway, if you come to this level, you will get more than 80% from whole mark, right? So if you give 5 marks for that question, you will get at least 4 marks, right? Then you have to convert this one. Actually, this is the third step, step 3, right? Then you have to convert this one into decimal format, right? To do that, again you have to subtract this value from this value, right? This value. You can write it like this. Here, this value 1 1 1 1 1 1. Okay, so 0 is here. So now you have to subtract this one. 1 from 1 means 0 0 0 0 0 0 1, right? So you get this value, and now you have, since this is a minus value, you have to, I will start from here. So since this is a minus value, you have to take this value, like, shall we take 3 4 5 6. Oops. Okay, so you have, since this is a minus value, actually can you see minus 21 minus 86 means minus 65 now. So minus value, since it is a minus value, you have to add 1, which means 1 0 1 0 0 0 1. And now if you convert this one into binary, shall we use the calculator?
Sir,
Yes.
so it doesn't make any sense. Now, what's the purpose of getting the 2's complement and converting the negative number to a positive negative number? Indicating the negative number and then doing the process and then adding 1 and making the answer minus again. Can't we get that
Anyway,
through the
if you
process?
convert this one, you will get the 65 now. If you convert this one 0 0 0 0 0 1 and 1, if you convert this one, let's see, 1 0 0 0. If you convert this one, yeah. So if you convert this one into decimal, you get 65 now. Am I right?
Sir, then why did we bother to subtract, use the minus sign for 86?
Actually,
We could have subtracted 20.
What I asked was, if you convert this one into binary decimal, you will get 65 now. That is the correct answer now.
The correct answer is minus 65.
Yeah,
no,
minus
sir?
65. Yeah, that's right. So here, actually the thing is, if you add 1, if there is a carry, carry means if there is a carry here, it is plus. Since if there are no carry, it is minus, right? That is how you decide whether it is plus or minus. Actually, the reason is I have explained this in first day school as well. When it comes to the computers, right? Actually, 2's complement methods are using 2's complement method is using in the computer. In a computer, it's more like it's kind of a actually in a computer there are only how can I say you cannot actually inside of a computer you cannot represent minus value, right? Because inside of a computer there are memory units, right? Memory if you take one memory when one block, it can hold 1 or 0, right? So but anyway you cannot say this is a minus value, right? So when it comes to the if you consider the computer, we have to we have to build a method to represent minus value, right? So even they one method is like we have discussed those things in first day school as well. One method is you choose one slot as a what you call sign bit, right? Okay, so I think these steps are clear. So the reason is like okay, so one method is shall I you give me
Sir, now in the subtraction, why can't we subtract 86 by 21 and put the negative sign at the end?
sorry?
Now 86 is the bigger number, na, sir? We have to
Yes.
subtract the 2, no? So why can't we subtract 21 by 86 and at the end of the sum, why can't we put the negative?
Yeah. But if you are a human, you can do that, right? So since you are a human, you can do that. But in computers, they don't know what is the bigger one or the small one. They only see 2 numbers. right? So actually here,
Then who is there to tell the computer that after 65 you should add a negative?
now, if there is a carry, that's why I said if there is a carry, if there is a carry, it's a positive number. If there is no carry, it's a negative number, right?
So I'm
Computers
talking about the step before that. Now, when you got 64 and you added 1 because it's negative, so that only now the carry is considered.
No. Let me explain here. This is your day school note. There are few methods to represent negative numbers inside of a computer, right? So one is this sign magnitude method. In sign magnitude method, the first bit, we call it as a signal sign bit, and these numbers are the numbers. Actually, these bits are the number bits, right? So you cannot use sign bit because it represents the sign of the that particular number, right? If it is 1, it is minus number. If it is 0, it's a positive number. This is one method, right? This is the one method. Then there is another method called 2's complement method. And 2's complement method, most computers use 2's complement method. There are several reasons. But even nowadays computers, some computers use 2's complement method. Here, so what you asked is, so this method, step 5 now. In step 5, we took this number. We get this number from step 4 now. Then you have, since this is in 2's complement format, you have to add 1 to convert into normal binary format, right? So no, actually 6 ones, no. So if you want to convert this one into normally binary format, you have to add 1, right? Now it is 1 0 1 1 1 1 1. Actually, if you add 1, there is no carry, no. So if there is no carry, it is minus. Like as an example, let's say you have value like 1 1 1 1 1. One. So if you add 1 here, there will be a carry, no? So then it is a positive number, something like that. But anyway, so these are the correct method to do the calculation. Actually, all these steps, we need to do all these steps to understand what is 1's complement and 2's complement. Actually, these calculations are done inside of the computer. So the reason is the computer cannot understand what is minus and what is plus. Actually, we use numbers to represent. We use some, actually, how can I say? It's like a workaround. It's like a workaround, and we only know it is minus value, but computer, we have to tell the computer, like how can I say, it's as I mentioned, like if you take a bus means, let's take a register. A register means it's a memory unit, and let's say if you take a 8-bit register, computer sees only ones and zeros. Like let's say it holds 2 3 4 5 6 7 8. So let's say this register holds a value like this. So computer only sees these numbers. It doesn't know it doesn't know whether this is a minus number or a positive number or negative number. But anyway, since we have to use minus numbers, we have to create a method to do these calculations. Actually, this operation, minus operation, let's say a minus b, this operation, actually computers cannot do this operation. Computers can only do plus operation, right? So you have to convert all these operation into this one, right? So that is what happens inside of the ALU. Even this is minus value, you have to convert all these things into plus value and do the addition, right? So that is why we have to create a method to convert this number minus b into some positive number. Let's say c. When it is represent it as c, it is a plus c, right? C means minus b, something like that. Right. That is why actually this is kind of a big theory, right? I cannot explain all these things because these things are coming in level 5, right? Some kind of a difficult theories, right? So basically this is the reason, right? So basically computer can do the addition. So if you want to do the subtraction, you have to make it as addition, right? So you use several you create a method. Actually you create a method to represent this value using binary and do the addition. Then you have to build a method to retrieve the value as well, right? So you just get some binary values, right? So computer doesn't know whether it's a binary value or not, right? You have to build a method to check whether it's a binary value or whether it's a minus value or plus value, right? So all these things, it is because computer cannot do this subtraction. Also, computers cannot understand. Computer cannot distinguish. Actually, computer cannot understand the difference between minus value and the plus value. But anyway, we have to use minus value now. That is why we are using the people, the inventors, they created this type of method, right? Actually, that is not the only method, but anyway, this method is using Two's complement method, using in several types of computer models, right? So even in nowadays computers, they use Two's complement value. But since even it is difficult to us, it is easy to compute, right? So within a few microseconds, it can do all these calculations, right? So anyway, since we have to learn these things, we have to understand the correct steps as well. But anyway, I will share some, if you need to know, if you need further information about these things, I will share some videos so you can refer to those things and get an understanding about it. Right. Okay. So actually, we have only 15 minutes. So actually, those parts, actually, those are straightforward, right? If you know the steps, you can get the full marks. That's all, right? So practice. You have to practice, and okay, what I was saying is you have to practice practice these, otherwise you will forget those steps.
Recording in
these days
progress.
computers, they don't use binary value directly. They use floating point numbers instead of normal binary values, right? There are some other values as well, like BCD, binary coded decimal, and there are some other representations as well. But anyway, nowadays computers, they use floating point numbers. I also explained about these floating point numbers in the day school. The reason is using small number of slots. You can represent a very represent a huge number, right? So even if you go through the theory, if even it is 32 bits, I think you know what is the meaning of bit, like number of slots. Let's say number of slots. Even if you use number 32 bits, you can represent a huge number, right? So you have to know how to calculate these floating point numbers as well. To calculate this one, there are several methods. No, actually there are two methods. I will explain in the answer script. Both methods are there, but I will explain the easiest way, right? Shall I take whiteboard? I will take whiteboard instead of this one. Then I can. Okay, so our number is 2154.256, right? So you have to convert this one into floating point number, right? First of all, you have to convert this one into binary format. That is the step one, right? So you have to use those method to convert this one. Simply you have to divide this one to 2000 and 2154 divided by 2, something like that, no? So you will get the answer. I will write the answer directly, 101. So this is the binary value. So here also you have to do this multiplication, no? 251 multiplied by 2. You have to do the calculation and you can get the fractional part as well. Let's say 0, 1, 0, 0, 0. In final exam, you don't need to go this far. 4 fractional numbers are enough, right? So this is the binary number. This one point, this one, right? Then you have to represent this number in this format. 1 multiplied by. So you have to take this binary value here. So to do that, you have, first of all, you have to write, sorry. To do that, you can, this number, 0, 0. Then this number, 0, 1, 0, 0. right? So if you move this binary point here, you have to represent like this, 2 to the power. So you are taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 steps to this side, right? So you can put 1 point this number multiplied by 2 to the 11, right? So number of binary places you have to put here. You have to put the number of binary places here, right? So here 1, 2, 3, 4, 5, 6. We are taking this binary point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 places to right left side now. So you can represent 1 point this number multiplied by 2 to the power 11. Right. So this is the binary representation of this value. Right. So you have to convert. This is also correct, but you have to get the floating point number. You have to convert this value into this format. Right. Which means 1 point some value multiplied by 2 to the power whatever number. Then in floating point, we have discussed these things in first day school. There are 2 parts. Actually, there are 3 parts. So this is the mantissa part, this is the exponent part, and this is the sign bit. Right here, can you see there is a sign bit? So in floating point number, the first digit is the sign bit. Is the sign bit, right? So you don't need to do those 2's complement kind of values, because there is a dedicated place to represent dedicated bit to represent minus value. All right. So there are actually you can take this directly, but actually we are not expecting you to do the calculation. But if it is IEEE single precision format, there are two formats: double precision format and single precision format. Here it is single precision format. So in IEEE single precision format, we represent this number, this floating point number, as this is the sign bit, and then 1 point this number, 1 point not this number, 1 point a number. Let's take this number as same. So 1 point some number multiplied by 2 to the power e minus 127. So this number 127, actually it is because it is IEEE single precision format, right? So there is a way to calculate this one as well, but anyway, if you put if you put e minus by minus 127, it is totally enough. You don't need to calculate this value 128, 127 if it is single precision format, because it's a kind of a default format in computers, right? Most of the computers use IEEE double precision or single precision format. So there's a unique number for each format. Since this is kind of a default format, you can get this number directly, right? You don't need to calculate everything, but this calculation is a little bit long, so you don't need to do those things. Otherwise, you won't be able to finish your final exam paper within that given period. Okay, so in IEEE single precision format, the floating point number is written like this, right? So you have to convert this number into this format, right? So I have to get this e to the power this value now. To do that, e E minus 127 is here. Can you see this one? It looks like this number now. So sign bit you cannot see here, but 1 point there is a number, right? 1 point there is a number. So here 1 point there is a number multiplied by 2 to the power some number. So this 2 to the power this number is equal to E minus 127 now. So E minus 127 is 11. Right now E is, you can take the value for E is 138. Right. So this is the E. Right. Then you get the answer for E. Then this 138. This is in decimal format now. So you have to convert this decimal format, this number, into binary number. So again, on 138, you have to divide by 2, and you can do the division. And I will write down the answer directly: 10001010. So this is the answer for this one. Like after converting this decimal value into binary value, this is the binary answer, right? So E means this exponent. Exponent is 10001010. Right. Then mantissa means this number. Right. From here. So we took this number as M, that is mantissa. So all these, you have to take all these numbers, and you have to put here. You have to put exponent here, and sign bit, since there is no sign value, this is 0. So basically you can write the floating point number like this: sign bit, exponent, the sign bit is 0 because it is a 0 value now. But here you don't need to calculate the sign bit because there is a dedicated place for sign bit, right? So before you are adding numbers, if it is a sign bit, you have to make this. If it is a minus value, you have to make this bit as 1, right? So exponent, you can write this 1 1 0 0 1 0 1 0, and mantissa you have to write all these numbers: 0 0 0 0 1 0 1 0, this number, right? So so this is the correct way to do this floating point calculation. And students make a lot of mistakes, right? Sometimes they forget to do this calculation, right? Sometimes they take this value directly, right? So then you will lose some marks, right? So here also there are lots of numbers now, lots of ones and zeros. Sometimes you might miss 1 or 2 numbers, right? Then you won't get full marks, right? So when you are writing these kind of big numbers, you have to be very careful, right? So check, double check each step, right? Because if you made a mistake when you are converting this number into binary, all other steps will be wrong, right? So you won't get the correct number, right? So you have to do these calculations very carefully. Then you can get full marks for that particular part, right? Okay, so this one contains lots of marks, so you can actually, if you memorize all these steps, you can get full marks for that particular part, right? So then actually in level 5 we will talk more about these numbers and how we use these numbers in inside of a computer, and especially when it comes to that level, you will understand why we cannot represent minus value, why we have to use a special method to represent minus value, right? Actually, those calculations are not a problem for computer, right? Even it is a very big calculation, it can do it within a few microseconds, right? So calculation is not a problem, but we have to have a reliable method to represent these things, whatever the minus value or plus value and everything. So yeah, that's that. What is the usage of this in the industry? Actually, not in the industry, inside of the computer, right? Inside of the computer, you have to use minus values now. I mean, early days they might use computers with addition only. Addition only computers, but nowadays you have to use both minus values, plus values, and everything now. So you have to have a proper method to represent minus value, right? So inside of the computers, they use these methods. Some computers use floating point methods. Some computers use two's complement method. Especially these microcontrollers, they use two's complement method. Since it is not complex method, they use two's complement method. But when it comes to floating point number system, the calculation is a little bit bigger than the other ones. No? So, but the advantage is using floating point numbers, you can represent a huge number. Right. So that is why we need these number systems, right? IRs in generally, yeah. If you want to build a computer, you have to know you have to know how to handle binary numbers, right? Because if you are the one, if you are the one who is designing the microprocessor, no? So that if that microprocessor cannot handle minus numbers, there is no point of designing that number. If you want to design a computer that can handle minus values, you have to use this kind of methods, either floating point number or sign magnitude method or two's complement method, right? So there are lots of drawbacks in sign. Actually, sign magnitude method is very easy. Like the first bit is sign bit, and other bits are like that is the number. That's a number, right? So, but anyway, there are lots of drawbacks, like because you cannot represent. Now, actually, if you dedicate one slot for sign bit, the range of the numbers you can represent is limited, right? So as an example, let's say you have binary number one. Let's say 4-bit binary number 1, 1, 1, 1. So this is the highest number. If you use 4-bit if it's a 4-bit number, this is the highest number you can get, right? So what is this number? This is 2 to the power 0. This is 2 to the power 1, 2 to the power 2, 2 to the power 3. This is 1. This is 2. This is 4. This is 8. So answer is 50, right? So this is the biggest number you can represent using 4 bits, right? So let's say if you dedicate this value to sign bit, what will happen? So what will be the biggest number you can represent? 7, no? So it's a big disadvantage, no? So that is why they use several methods to actually increasing 1 bit in a computer. It's a really costly thing, right? When you are designing a computer, increasing 1 bit is a big thing, right? Because it the value, the costing will increase exponentially, right? So that is why the memories are also like I think some of you know these things, like if the cache memory is high, that processor is very expensive, right? There are processors with 16 MB cache memory, 8 MB cache memory. Those processors are really expensive comparing to those low cache memory things. Like that is why. When you are in computer hardware, if you want to increase something, it's kind of a costly thing, right? So you have to save these. You have to be very cautious about the cost, as well as you have to represent. You have to you have to take maximum maximum. Like how can I say, maximum usage, right? You have to use it. You have to use all the resources as much as possible, right? So that is why they are. If you dedicate one thing for sign bit, it will be a huge disadvantage. But when it comes to floating point number, because of that method, you even it is 4-bit number, you can represent a huge number. Actually, we are talking about 32-bit kind of things now. Actually, in floating 32-bit floating point number can represent the maximum value of IEEE floating point number is this one. It's a huge number. It can represent this range, 2 to the power 2 minus this value to 2147483647. So this range minus this value to this value, right? So it can represent this much of numbers using 32 bits. But if you use this value, if you use 32-bit binary, it's 0 to let's say 32, 31. Now if 32 means if you use all 32 bits, it is 21474. It's a huge number, but if you dedicate 1 bit for binary number, this number will what is the I don't know why it is 31. I can't remember the exact number. If you use 32 bit, like if you dedicate first bit for sign bit, you have only 31 bits now. So you cannot represent this much of value. But using floating point number, you can represent this much of values, right? So that is why floating point number has sign bit because of this representation method. It can represent a huge range, right? So those are the reasons to have those kind of things, improvements. Like first of all, they use sign magnitude method. Then they realize this issue, right? Then they introduce this two's complement method. Two's complement method is a kind of effective method. It uses whole 32 bits, right? 8-bit or 32-bit, because they don't need to have a separate sign bit, right? So, but when it comes when the improvements and with with the evolution, the computer become faster, and they have to be very fast now. So they have to very fast as well as inexpensive. So they have to use separate methods to represent these kind of things using limited resources, right? So so that is basically the idea to have this kind of complex calculation, but you don't need to understand those things right now. If you can understand if you can memorize those correct steps, and if you have a basic idea about these representation and the difference between these representations and why there are several types of representation, that is enough for this level, right? So yeah, that's that. So those are the things I was planning to discuss with you today. But anyway, I think you may not understand everything, but if you go through this answer script and all, you can understand it, right? Normally, these kind of logical, mathematical things you cannot understand it. There are people, but most of us may not be able to understand in our first go. But if you practice and if you go through again and again, you will understand it, right? So that's that. So those are the things I wanted to cover here. Okay, so do you have any questions regarding those parts?
Hello, sir.
Yeah.
This is not about this part of section. About the day school, it is mentioned in active diary. This is a second day school, but you said this is a revision class.
Yeah, that's because it is. I think it is not a revised activity diary. I don't know where did you find. The revised one is available in the LMS.
Yes, sir. I am always checking that, but it's not available, I think.
So okay. So I will ask them to. Actually, the thing is, we haven't finalized our activity schedule because there are some complications like resources, availability of the resources, and availability of the lab instructions. Even we haven't grouped you yet. No. So it might take a week or two to finalize everything. After that, in 2 weeks' time, after 2 weeks, I will post the exact timetable. But for now, there are only one activity which is coming on next Friday. Next weekend, Sunday and Monday. After that, we will schedule lab sessions. Actually, after day school 2, we will schedule lab sessions. And in 2 weeks, I will provide you all the information, like who are the instructors. Actually, not like other courses. All the labs are done by special lab instructors because we need. They have to be. Not like other subjects. Even industry people can do those labs, but these labs, they are very specific kind of things. So we need people who has knowledge in that area. So we have to recruit new people, and we already recruited them, and we are giving some training these days. So after that, we will give you the correct plan. Right? I will message you all. Right after finalizing everything, we will message you all. So anyway, since this is going on a very slow pace, you can manage everything. Like normally activities like there will be only one activity per month. Like sometimes more than 1 month, it will take. The gap between two activities. Sometimes there might be more than 1 month. Right. So anyway, I will share all the information within 2 days. Even the course material is not sent yet. I don't know, because of some problems in the printer. So they have this font problem. So we are working on it, and hopefully we will be able to. We are hoping to send all these course materials, printed ones, within this week, and finalize all the activities in 2 weeks' time. Right. So I will post all the information in the announcement section for now. After finalizing the activity diary, I will ask them to upload the correct activity diary into the learner support page as well. So anyway, regarding all the information regarding this course is available in the announcement. Whenever if we are changing or if we are planning something, we will announce you through the announcement section. For now, please check the announcement section daily, so you won't miss anything. The recording, actually lab session. In lab sessions, I explain these things in the introductory session as well. In lab sessions, there are several labs. One is computer architecture lab, and you are doing some assembly programming there, and you run those assembly program on a simulator. And there will be a networking lab as well. You use simulator calls Cisco packet tracer to simulate the computer network. Then again, there is this communication partner, so amplitude modulation and frequency modulations. There will be lab sessions based on amplitude modulation and frequency modulation. So it is also done using a simulator, right? So there are lots of simulators. So that is why we cannot ask tutors to do these labs, because we need people who has knowledge on these simulators and everything, right? Yeah, that's that. Yeah, recording, Day School 1 recording is available in the LMS, no? So I have already uploaded that one. I will upload this one as well. Right after the weekday session, I will upload the recording. So all the recording will be uploaded into LMS, right? Recordings, Day School note, Day School presentations, all the information. Also, please go through those additional resources. I have uploaded a few YouTube videos and some websites which about this number system calculation. So please go through those things as well. Actually, from those videos, you can get a very clear idea about these number systems and everything, because we have very limited number of hours for our sessions. But actually, these revision sessions are not included in activity diary. Not in curriculum as well. But since this is kind of a hard, difficult subject, I thought it is better to have a revision session in between 2 day schools, right? but anyway, even we are having a revision session, we cannot explain everything. So you have to go through those resources, and if you find if you think you can if it is difficult to understand, you should go through the resources. Non-programmable calculators, especially those MX ones are okay. Can't remember them. MX991, MX100, FX ones are okay. FX100, FX991, those are okay. FX100 is okay. It's kind of a basic one. FX991 is also okay. FX991 is kind of a little bit advanced one. Yeah, FX ones are okay. Even FX991 ES ones are okay. FX11991 MX, FX991 ES kind of an advanced one, but I don't think you need that much of a advanced calculator. But FX100 FX100 is more than enough, right? You can do everything in FX100. Okay, then so we are hoping to have another revision session after day school 2, but in between that, if you need anything to be if you have any question or anything regarding the course, please put it in the help wanted section, so we can discuss those things there. Also, you can discuss with your own, with your colleagues as well, right? So if you know the answer for any post, you can reply to them, right? You don't need to wait until I reply. Actually, the networking part is done by Mr. Salia, and he will explain more about networking. I saw a few questions regarding the networking as well, IP calculation and everything. Mr. Sali is the Mr. Sadia is the person who is coordinating that part. Other parts I am coordinating. So I'm the chief coordinator here, but networking part is handled by Mr. Sali, right? Okay, so okay, then I will stop here. I hope you got some information. You may not get fully. You may not be able to understand everything, but I hope you had some knowledge in this session. Okay, so thank you for participating. Do you have any other questions? Okay, so we'll meet in the next session, and please keep in touch. Read the books, go through the videos, and do some activities. Like each and every session, there will be some activities. Right, answer is also will be there. So first of all, try to answer those questions without seeing those answers, and then you can evaluate yourself and do some calculations. You have to practice. You have to practice very well. Otherwise, you will forget those methods. Also, do it very carefully, right? Because if you made one simple mistake, the whole answer will be wrong. Right, so do it carefully, actually the answer is practicing, right? If you have a good practice, yeah, you made very less mistakes. Okay then. Okay, so thank you for participating. We'll meet again. Thanks.